Today we are going to be talking about the idea of even and odd functions. They are tied to the different types of symmetries, and very similarly to symmetry, a function could be categorized as being an even function. It can be categorized as being an odd function, but it can be neither of those two things. It cannot be both, okay? So it cannot be both even and odd, but it does not have to fall into one of those categories. So let's talk about each of these different categories of functions. An even function. An even function is symmetric with respect to the y-axis. So if it has y-axis symmetry, we would be able to call it an even function. Now, this is the mathematical notation that you will see, and we'll talk about it in real-world speak here. But it says that if I plug a negative x into my function, that what I get is the original function, which is the same as the test we were just using on our warm-up, right? If it had symmetry about the y-axis, we plugged in the other letter. We plugged in a negative x, okay? Now, I will tell you that I think the easiest way to test even and odd functions is that when you're doing it, to write your function in function notation, not y equals. So I would rewrite all of them as f of x instead of y equals if it starts out as a y equals. And then you're plugging in negative x. And here's the key for an even function. And in an even function, when you plug in negative x, all of the signs will match exactly to the original. They all stay the same. So if this were to have started out as a y equals x squared, I would just rewrite it as f of x equals x squared, plug in a negative x, and compare your signs. If they're the same, it's even. So an example here, given f of x equals x squared. So this is our original. This is our what we're comparing to. I would try evaluating it for f of negative x, which is what we had kind of practiced back in our section when we were evaluating functions for negative x. This is kind of what we were prepping for. Okay. So as I plug in a negative x to our function here, that is x squared. We've now had this conversation a lot over the last couple days, is that when I raise something to an even exponent, it will turn out positive. So f of negative x equals x squared. Compare it to the original. So my original was this, right? The original one I started with was x squared. When I plugged in negative x and cleaned it up, I got x squared again. And what we're supposed to do when I say compare is compare the signs on your terms. We've got a positive and a positive. Those are the same. And if they are the same all the way across, and I get that this is a very basic example because there's literally only one term to compare, but it could be a polynomial with multiple terms to compare, and we go through and we compare all of those signs. And as I look at them, if I were to say that they are all the same, then it's identified as an even function. Okay? Looking at our graph to find an even function, remember that it would have y-axis symmetry, y-axis symmetry to be an even function. And there is a picture of y equals x squared or f of x equals x squared. Questions on that? People another minute or two on this page. Anyone still need this page? Okay, let's go through that same conversation for an odd function. For an odd function, it will be symmetric with respect to the origin, meaning I can spin it around the origin, right, and it'll match back up with itself. This time, and this is where the mathematical notation gets a little bit tricky to understand, is mathematically what's happening is when we plug in a negative x, we get the exact opposite. That's what this little sign means, the negative version of our original function. Now, in more like real world speak, what does that mean to us? Again, write my function in function notation. I'm going to plug in a negative x. And if I were to identify something as being an odd function, I would have ended up with all exactly opposite signs of the original. So if all the signs flip to opposite of what they started, it's an odd function. So again, showing that here's my very basic sample example function, f of x equals x cubed. Oops, I said is an even function. That's an odd function. Sorry, is an odd function. Let's look at how that would show up in our testing here. If I compare negative f of negative x to the original, f of negative x, when I plug in a negative x, simplifies down to raised to an odd exponent. We keep whatever sign was there. If I compare that to the original, plugging in just a plain old x, the original was a x cubed positive x cubed. And again, even odd, you go through and you compare the signs on each term. And again, this one only has one term, so there's not a lot to compare. Those signs, a negative and a positive, would be opposite. And if I go through the entire function and every sign is opposite, I identify that as being an odd function. What do odd functions look like on our graph? Remember, I can spin that 180 degrees, and it would match back up with itself around the origin. Any questions for me? Anyone still need this page? Okay, so we could look at a picture. So remember the two options. Symmetric around the y-axis or symmetric around the origin to identify even, odd, and notice they will always give you an option of neither. It does not have to be even or odd. Not all of our functions were symmetric with respect to the y-axis or the origin, right? So let's look at some options here. If we are determining based off of a visual, does that picture have any symmetry? Yes, symmetric with respect to y-axis, which matched up with which of the ones we just talked about? Even. You got it. For my notes purposes, I'm going to write more than I normally would here. Because it is symmetric with respect to y-axis, we would say that it is an even function. All right. Okay, let's look at another one here. Does that picture have any symmetry to it? X-axis is not going to help us at all today. I should start with y-axis. Y-axis or origin? No. It doesn't have any symmetry, so I don't even have to remember which one goes with which, right? If it doesn't have any symmetry, it can't be even or odd. So the option then would be it is neither even or odd. Neither of those two options. Okay. Last example of a picture. Symmetry. the spin symmetry, right? If I were to spin that picture 180 degrees, it would match back up with itself. So I would say symmetry about the origin, and that one, origin, odd, both start with O. That might help you remember which one goes with which. Symmetry about the origin is an odd function. All right. Questions on the visuals? Okay. So it is, again, you will have to take a second to remember if you're looking at a picture to be able to identify which symmetry matched with which, even or odd. And my little trick is that odd and origin both start with an O, so then y-axis goes with the other one. Okay, I don't know a link between those two words, but odd and origin maybe will help remember that those two link together. Okay, so then now let's try some equations. I don't have a picture to look at, and I'm going to do an equation. And again, if the equation were handed to me as y equals, I would write it as f of x, just because of our test is plugging in a negative x, and then I don't get confused with the whole y letter being in there, all of that. But it just says, so all we do for our test, even, odd, or neither, is we plug in negative x. Here's my original function. I'm going to plug in a negative x, clean it up, raised to an even exponent gives me the original, or gives me a positive, and we compare to our original, which is just plain old f of x. Now I do have to compare every sign, so I would go across every term and compare their signs. Positive and a positive is the same. A positive and a positive is the same. If they are same all the way across, it is an even function. Okay, let's try another example. 7x cubed minus x. Okay, so first things first, I take that function and I plug in a negative x and I clean it up. Careful, that one gets a little tricky with the minus the negative in there, right? Get both of those negative signs in there. Let's talk about cleaning it up. A negative x cubed, we keep the sign because it's an odd exponent, right? So then it would be a positive 7 times a negative 1, or a negative, it's going to turn out to be a negative 7. Okay, we all okay with how I cleaned that first term up? And then I have minus a negative. Two negatives in a row makes it a positive, right? Minus a negative is a positive x. We compare this to the original, which was 7x cubed minus x. And we look at the sign on each term. We went from a negative 7 to a positive 7. Those are opposite signs. We've got one positive, one negative x. Those are opposite signs. And if I go through and I say opposite to everything, then it is odd. So again, how do I remember that? Opposite, odd, and origin all start with O, right? So that might help you again as you're remembering, because it's a lot to remember, and I get that. So little tips and tricks like that might help you when testing for symmetry and for odd, even, and your options are odd and even. Remember, the word odd starts with an O, and it's also the one that has symmetry about the origin and has all opposite signs when we plug in a negative x. So we would call this an odd function. Okay, let's look at one more example here. h of x equals x to the 5th plus 1. And again, we start by just plugging in that negative. Negative raised to an odd exponent will remain that sign, so negative x to the 5th. Compare it to my original. Okay, and then this is the first time we've seen this happen today. As I scan through here, we have a negative and a positive, which are opposite signs. I have a positive and a positive, which are the same signs. And so if we get some sort of combo here, some of them switched and some of them didn't, then it is neither even or odd. They have to all be the same, or they have to all be opposite. And if we've got a combo, it is neither even or odd. It means it does not have that symmetry about the origin. It does not have that symmetry about the y-axis. Functions do not have to fall into one of these two categories. Okay. Any questions so far? Now, I will tell you that on an individual basis, what we did yesterday with testing for the x-axis, y-axis, and origin symmetry, and what we do today, testing for even and odd, on an individual day, it's pretty easy, pretty straightforward. Plug this in, check it out, follow my notes. When I get to an assessment over this, and I'm just giving you some practical advice here, you're going to want to go back and review these two things because you forget which test did what. Okay? So yesterday maybe seemed easy, today maybe seems easy, but when I put both of them in front of you and don't remind you, sometimes we confuse one for the other, or how was I supposed to show this, right? So just make sure you go back and look at the difference between even, odd, and symmetry, because they are so alike. All right? Okay, now let's talk about a little hint, and maybe somebody was trying to pick this out as we looked, but here there is a relationship between the exponents. So we're calling these functions even and odd, and we're seeing things that are even and odd show up in our picture, right? And maybe somebody was like, okay, well, even, if it's even exponents, does that always go with the word even for our function? Okay, yes and no, so be careful. As we look at this, and I'm going to add something to that neither column as well, is there a relationship between the exponents? If I tell you that this is an even function, look at the exponents. They're all even, right? So if it is an even function, if all exponents are even, then it is an even function. That's a little hint. Okay? Look at that next one. It's an odd one. Now this we need to have a little conversation of, I've got an x to the 3rd, clearly an odd exponent. What about that last one? I just have a 6x. What's its exponent? A 1. Is 1 an odd number? Yeah, so that's kind of why I wanted to talk about this one right here. This guy right here is an odd number, isn't it? And if all of those exponents are odd, again, noticing our exponents here, all even, all odd, our function is odd. Okay? And again, notice I'm stressing the word all because look at a function that is neither even or odd. And this is where we, if we're going too quickly, might get confused. Our first exponent is even, isn't it? Our second exponent, which we don't see, but is a 1, is odd. And notice we've got a combo there. And if we have a combo of even and odd exponents, our function will not be in either of those two categories, even or odd. However you want to write that for yourself, combo of even and odd exponents. Not all the exponents are the same, even or odd category, whatever makes sense to you. But the biggest thing I want to talk about on this is constants. What is the exponent on a constant? Okay. Note, if it is a constant, which means just a plain number, that would be the same. So ours is a 1 That's the same as a 1x to the, but there's no x there, which means it would be an x to the 0. 0 would behave the same as an even exponent because it's going to keep whatever sign is there, okay? So if it is a constant, it would behave like an even exponent. So we could like put a second example here. Something like x to the 8th plus 3. Okay, that would also be an even function because its missing exponent, which is not there, is a 0, which would behave like an even number, and it would keep this sign the same because all of my signs have to be the same at the end, right? So just keep that in mind, is that constants would be the same as like an even exponent. Questions? Did anyone still need this page? Nope. Okay. Let's run through our check for understanding. Grab your markers, please. Okay, first one, determine whether each function is even, odd, or neither. Then determine whether it is symmetric to the y-axis, the origin, or neither. You should be able to answer that if you remember which one tied to which symmetry. You shouldn't have to test for it again. You can use our little shortcut at the end if you remember that, or use the test. If you are unsure of that shortcut, you are comparing f of negative x to f of x. Remember, two answers on this one. Symmetry is your second answer, even or odd, and then what symmetry it has if you say that even or odd. Now, if you don't say the word even or odd, you're going to say none for symmetry, right? Seeing a combo around the room of people who use that kind of shortcut that we talked about at the end, and then people who are still plugging in the f of negative x. That is 100% a personal choice and what you're more comfortable with. Obviously, the plugging in is a little bit more of the work, so I'm going to show that up here super fast. But guys, I saw a really good work around the room. So I'm comparing f of negative x to our original. If I plug in a negative x, raised to an even exponent, I would get all positives. X squared would come out positive. This would come out positive with the negative sitting in front of it, would not change. That's still going to be a minus x to the 4th plus 1. So let's compare, take all of it here. Compare that to our original as we look at each sign. Same sign, same sign, same sign. If it is the same sign all the way across, that is an even function. Those that use the shortcut, even exponent, and a constant behaves like an even exponent. So even means it's an even function. Even functions have symmetry about the y-axis. Questions? Okay. Let's do one more. 1/5 x to the 6th minus 3x squared. One-fifth x to the 6th minus 3x squared. Think on yours again. We are like 2 seconds from being done, and then you can go, yes. Okay, seeing great answers as we walk around the room. Again, I can go the long route of plugging in and comparing. When I do that, the thing I like about these problems is they try to confuse you with where things are positive and where things are negative. Both of our leading coefficients are negative numbers, and does that impact us? Negative x to the 6th comes out positive. Negative x squared comes out positive, times the negative 3 will stay negative. Comparing that to our original, if I get rid of my work there, we've got same sign positive here, same sign negative here. If it is same all the way across, it is an even function. And again, if we were to go back, we can just look at the exponents. Even exponent, even exponent. I only have 2 exponents to compare here. Both are even, which means my function is even, and y-axis symmetry if it is even. All right. Your assignment is, again, on my math lab. It's the one that is labeled as 007 today.